Hello everyone, welcome to the final section of notes for this chapter on conics. We're going to talk about transformations of conics, so we're going to move parabolas, hyperbolas, and ellipses around. We're going to talk about standard form of a conic. Before we can do that, we need to learn how to do something called completing the square, which is the best picture I've seen so far. So every conic I've given you has been in standard form. They have squared binomials. Since they require us to square the binomials, we need to learn how to write an equation of a conic in standard form by completing the square. And here's what you need to do. Put the x's and y's together, and then do GCF of the x and y's. Just the numbers, not the x's. No coefficient on the squared term. Leave a blank for the third term in the parentheses. To fill in the blank, take half of the second term and square it. We must balance it by subtracting outside, or what I'm really going to do is I'm going to add to the other side. Be careful with the GCF to make sure you're adding the right thing. Then factor, and you should have a squared binomial. It's easier if we see an example, so in this problem, I'm going to group the x together and leave a blank spot, and I'm going to move the 7 over. No y's in this problem. To complete the square, I'm going to take half of this term and square it, which will give me a positive 9. Balance it by putting a positive 9 on this side. Factor, I've got x minus 3 squared now. Negative 7 plus 9 will give me 2. That's completing the square. I can use this to solve the equation. This isn't really part of this section, but I'm going to go ahead and show you anyways. Take the square root of the other side. It's always plus or minus. And then I can get rid of the 3 by adding it over. That's another way to solve a quadratic if you don't want to use quadratic formula. But again, the only thing I'm really working on today is completing the square. Let's try it here. This one is a little bit different because there's a number with the x squared. I said there couldn't be. So I'm going to pull out that number. Leave the blank spot. Now fill it in. Take half of this term and square it, and you get 1. But I'm not going to add 1 to this side. I'm actually going to add whatever I added over this side, which was really 3. So now what do I have? I have 3x plus 1 squared equals 8. So that's completing the square. Again, you can solve if you want to. Divide, square root, subtract 1. But for now, let's talk about conics again. Look at this one. This is an ellipse. How do I know it's an ellipse? It's got a plus in between them, and there's x's and y squared. This is going to move left and right opposite of whatever's with x. So if this is x plus 2, it's going to move left 2. This is going to move up or down opposite of the sign. So if it's minus 3, it's going to move up 3. If it's plus 4, it's going to move down 4. I'm going to write down my transformations, and then I'm going to completely ignore them. I'm going to do the problem like I normally would, and then I'll add the transformations back in. Okay, like I said. The center is really at negative 1, 2. It's not at 0 anymore. So this one right here would be x plus 1, so left 1, and up 2. How would I draw this? Well, I would go 2 and negative 2 on the x-axis, 3 and negative 3 on the y-axis. But since I went left 2 and up, I went left 1 and up 2 for every x value, I'm going to subtract 1. For every y value, I'm going to add 2. So the 4 points that I drew are now going to become 1, 2, negative 3, 2, negative 1, 5, and negative 1, 1. So this is my new ellipse. The 4 points that I originally would have drawn, I'm going to move. And I'm going to answer all my other questions the same way. The foci of this thing should be square root of 5. Since it is taller than it is wide, it's going to be 0, comma, plus or minus the square root of 5. But I have to subtract 1 from the x to go left 1, and I have to add 2 to the y. So there are my new points for the foci. It's okay if you write this as negative 1, comma, 2, plus or minus the square root of 5. How about for parabolas? Okay? Up, down, left, right, same concepts. Let's write this in the correct form. But to do that, I'm going to have to complete the square. On this side, I've got x squared minus 4x. On this side, I've got 8y minus 28. What is this missing? We'll take half and square it, and I get a plus 4. Balance it with a plus 4. Factor it. I'm going to get an x minus 2 quantity squared. Here I'm going to get an 8y minus 24, which is going to be x minus 2 squared equals 8y minus 3. So this new parabola that we see up here is really the same thing as this parabola, with the exception that it went right 2, up 3. I'm going to answer every question that I have. Foci, directrix, vertex, all of that. But then for every point I get, I'm going to move it right 2 and up 3. So, since 4p equals 8, and remember we always take whatever's in front of the non-square term and divide it by 4, the focus should be at the point 0, 2. That should be the focus. But since it went right 2 and up 3, I'm going to add 2 and I'm going to add 3. So my new focus is at 2, 5. My directrix is always the opposite of whatever the focus is. So it's going to be y equals negative 2. But if I go right 2 and up 3, the right 2 doesn't change it. The up 3 does. Now I'm at y equals 1. So I've just transformed what I had into the new one. The vertex used to be at 0, 0. Now it's right 2 and up 3. Hyperbolas, we're going to do the same thing. We're going to shift them left, right, up, or down, but we're going to answer it based on no transformations. This problem gets tricky because it's not in the correct form. So let's rewrite it. 9x squared minus 72x. I think it's minus 16y squared minus 32y. I think that's right. Minus 16y squared minus 32y equals 16. So let's set this up for completing the square. If I group these two, and I'm going to group these two, I'm going to pull a 9 out of this thing. That leaves me an x squared minus an 8x blank. Pull the negative 16 out of this. It's going to leave me a positive y squared, a positive 2y blank, and a 16. So let's complete the square. Take half of it and square it. That'll give me a positive 16. Take half of it and square it. That'll give me a positive 1. So on this side, I have to balance what I've just done. I didn't just add 16. I added 9 times 16. So let's balance it. So let's add 9 times 16 over here. On this side, I didn't add 1. I added 1 times negative 16. So let's add 1 times, it's actually a negative 16. I know it's negative 16. It's 1 times negative 16. If you clean all that up, you get a 144 on this side. And on this side, you get a 9 times x minus 4 squared minus 16y plus 1 squared. But even this isn't the standard form yet. This is just completing the square. What does a hyperbola or any of these have to be equal to? Hyperbolas or ellipses have to be equal to 1. So I'm going to divide everything by 144. And now I've got x minus 4 quantity squared over 9 divided by 144 is 16 minus, that's how I know it's a hyperbola, y plus 1 quantity squared over 9 equals 1. Now I have the hyperbola I'm going to work with. What am I really going to think about? I'm going to think about x squared over 16 minus y squared over 9 equals 1, but it's been moved to the right 4 and down 1. So I'm going to answer all of my questions based on this, but then I'm going to add 4 to all the x's and subtract 1 from all the y values. So that's what my graph's going to look like now, because it went right 4 up 1. I'm sorry. Right 4 up 1. Yeah, sorry, I went down 1. I don't know why I said up 1. Right 4, down 1. So I'm going to find my foci. The foci, you do square root of this and this. So that's going to be square root of 25, which is 5. Remember that this hyperbola opens sideways because the x squared is first. So the foci should be at plus or minus 5, comma 0. But I have to move them to the, what was my transformation again? To the right 4 and down 1. So if I go down 1, that's going to make both of those negative 1. If I move positive 5 to the right 4, I'm going to get 9. If I go to the, and if I go negative 5 to the right 4, I'm going to get negative 1. And the vertices are the same thing. It should be at 4 and negative 4. But now I just move them. The asymptotes are harder. The asymptote should be this because it was 3 squared and then it was 4 squared. So this is my asymptote. I'm going to replace the x with the x minus 4 to make it go right 4. I'm going to replace the y with the y plus 1 to make it go down 1. And I'm going to solve my equations out. So now I have 2 asymptotes that have been transformed. And there's my new hyperbola. Remember, you have to put it in the form that you're used to, transformational form. What about general form? So this is where it gets a little bit complicated, as if it hasn't gotten complicated yet. Take a look at this. This is general form or standard form. The x squared and the y squared are first. If it's addition, it's going to be an ellipse. If it's subtraction, it's going to be a hyperbola. If one of these squares is missing, if there's only an x squared or a y squared but not both, it's going to be a parabola. Then I'm going to do some sort of completing the square here to see what my equation is. Sometimes it doesn't work out at all. Not every equation that's written like this is going to be a conic section. Okay? And here's what I just said a second ago. Let's sketch the graph of this. Well, the first thing I need to do is figure out what it is. So I'm going to, well, when you look at this, it looks like it's going to be a hyperbola. It's x squared minus y squared. So it should be a hyperbola. I'm going to pull the 9. I'm going to put these two things together. So I'm going to rewrite this as 9x squared plus 18x minus y squared plus 6y equals 0. And I'm going to complete the square. Pull the 9 out of the first one, pull the negative 1 out of the second one, complete your square, and balance on the other side. If you do that, this becomes 9 times x plus 1 quantity squared minus y minus 3 quantity squared, but it's still equal to 0 because these two things canceled out. If I divide everything, I can't have the 9 here, so I divide everything by 9. If I divide that by 9, these will cancel. If I divide that by 9, the 9 goes on the bottom, and it's equal to 0. But wait a minute. It has to be equal to 1. I can't make this equal to 1. This might look like a hyperbola, but because this is not equal to 1, it's not a conic section at all. In fact, if you solve this equation by taking square roots, you can see the math right here, you end up with 2 different lines. Just 2 lines. This becomes just a graph of, looks like an X. This is called a degenerate conic. In this case, a degenerate hyperbola. It looks like a hyperbola, but when you actually do the arithmetic to solve it, it doesn't become a hyperbola like we're used to seeing. It wasn't equal to the one that we wanted. What if you had a problem like this? It looks like it's going to be an ellipse because it's x squared plus y squared. It looks like it went right 1 and down 1. It looks like the x is going to be plus or minus 1 and the y is going to be plus or minus 2. But it's not equal to 1. Because it's not equal to 1, we can't solve this problem. And it's really, you can't even graph it because this thing squared has to be positive, this thing squared has to be positive, and this positive plus this positive can't equal a negative. So, summary for today. Transforming your parabolas, your hyperbolas, your ellipses, and then completing the square to find what kind of conic section it is. Maybe it's a conic section, maybe it's not.